Good evening, everyone. I am Siddesh Surenshi, President of Revolution Software Development Club under the Department of Computer Engineering, Vishwakarma University, Pune. I welcome you all in this session, Introduction to Debugging, and we hope that you find this session useful. As many people have discovered, resolving a bug in a program can be a tedious process. Thus, we are conducting this session to help you resolve bugs in the shortest amount of time and in the most efficient manner. Let me now introduce Elvin D'Souza, the tech lead of our club, and he will be explaining theoretical aspect of debugging in this session. Over to you, Elvin.
Hi everyone. Thanks, Siddesh. So this demonstration is mainly aimed at those who are new to programming. So some of you who play video games might have heard of the term bugs or that an app is buggy. So first we're going to start off with what a software bug is. So it's basically a flaw in the design, development or operation of software. That's it. So these bugs, they cause production of an incorrect or sometimes unexpected result, or the program sometimes behaves in unintended ways. So we have this term debugging, which is debug. That is the process of removing bugs from code. And a debugger is a program that allows us to perform this debugging, this process. So the first type of error you're going to likely encounter are syntactical errors. So syntax, that is your programming language syntax. And that means your programming language grammar. These rules must be followed. So these are things like your missing statement delimiters, that's your colon in C, missing keywords. And now your compiler or interpreter will always catch syntactical errors. So if it's a C program, it will refuse to compile. And the next type of error you will see is semantic or logical errors. Now, when we talk about logic, we are talking about the meaning of the statements. So something can be syntactically correct, but the semantics are wrong. It will not perform the way you intended it to. So depending on the language and the warning levels and the configuration, your compiler or interpreter should pick up on a lot of semantic errors too. Like for example, in a C program, you will see the compiler complain about semantic errors like assignment, variable assignment with invalid data types. So you might have seen before how inspecting the live state of your program mid execution could be very valuable, and we're going to expand upon this in this session. So we're going to go through the stages of debugging. So if you know that a program contains a bug, the very first thing you should do is make it happen again. That means reproduce it. So this can be done through changing input values. Then you check the previous, you can even scroll back through your terminal or your command prompt to check what the previous input was that gave us the incorrect or undefined output. Then once you've done that, once you've reproduced the bug, the next thing you should do is characterize it. So here you have to really sit down and think. So use your intuition to formulate what could be going wrong. Use your reasoning skills, your analytical skills. So how much can we change the inputs and get the same error? Is it a different error? How big is the error? Now begin trying to localize the bug. So this is most often the hardest part, and this will absolutely take the largest share of your time. Okay, so as C programming students learning your introductory courses to C, my guess is that you'd be using printf statements all over the code. After every few lines, you'd be using printf statements. You add line number, and this would probably be to check where the bug is located, right? And we call this a primitive approach, and I wouldn't recommend using this approach. And if it's a syntactical error, you'd be checking the traceback in Python, that is, or error messages from your compiler, and it'll always show the line number. So it'll show your program file, the file colon line number, and then you'd usually go and check the output, the error, the output, and you'd see what went wrong, what is the syntax error, and on what line. So once you've found the offending statements, modify it, make fixes, and try to reproduce the bug again. Now we're going to talk about localizing the bug. Again, I just said that this is the hardest part of debugging. This will take the maximum amount of time. So the scientific method will really help you out here. So the first thing you should do is study the data. Study your inputs and your outputs. That's it. The second step is hypothesize. So again, make guesses about where the bug might be. We call this guesstimates. That means you actually, it's not a wild guess, but it's using your experience and what you've seen before, what you've learned before. Make a guess about where the bug might be, what it could be, and then experiment. Run your test to challenge this hypothesis. So here we'll be setting something called breakpoints all over the program to achieve this. Okay, so now we're going to do the last step is repeat. After reasoning with your new data, if you've not found where the bug is, repeat. If you have, then you can break out of this loop. This is basically your algorithm. And keep repeating until you find the offending statements. Now, I will put a disclaimer that there are no debugging rules set in stone. You have to use what works for you personally. And for me, rubber duck debugging is called rubber duck debugging. It works the best for me. So just to explain it, this is a method of debugging code, and you articulate the problem in spoken or written natural language. And this entails debugging your code by forcing yourself to explain it line by line, statement by statement, to an inanimate object. That means talk to yourself, basically, or to another person. And you can do this with a friend or one of your professors too. Now, what are the types of errors that require involved debugging? So I'm not talking about debugging in general. I'm talking about involved debugging. So as we talked about before, the syntax errors, these are compiler errors or interpreter errors or tracebacks, like in Python, and these would produce a wall of text. And as a new programmer, this can be really maddening, but for little more advanced and experienced programmers, these are like a helpful grandmother. And these are really helpful. These wall of text outputs, as they're called, they're really helpful to quickly find and fix the bug. And they're really easy to fix. Now, the second type is your runtime errors, your semantic errors, your logical errors. So these are the ones that can keep you up all night. And these are the ones that will require a methodical and very involved debugging effort. So how do you debug programs now? So debuggers, they let you run through your program to specific points. The debug program will let you look at variable values during execution, and it will let you step through the program one statement at a time. So just think about how useful that could be. Think about the utility of this. Now we'll be using the debugger in Visual Studio Code on Windows 10, and that comes with a graphical UI. So you don't need to use any command line debugger. You don't need to type in any statements on the command line. If you're not comfortable with the command line yet, it's completely fine. So one last thing is, if you're wondering why VSCode in particular, it's because from what I have seen, it's the most popular editor among all our computer engineering undergraduates at VU. And Windows 10, because obviously it's the most popular operating system out there. Okay, so now I'm just going to run quickly through a video. This is really easy to do on your own, really easy to reproduce. And the steps are just install extensions, create a file, create a test code, and try to run the debugger on it. That's it. So the first thing you do is open up VS Code. Then Control-Shift-X or click the extensions button in the bottom, in the left panel, and that will open up your extensions view. Now type Python in the search bar, and what this will do is it will search up the Visual Studio Code marketplace that's hosted by Microsoft, and it will search it for Python extensions. So the first result that should come up is the most popular one. It's 70.7 million installs, and make sure it's the most popular one, and see it's being provided by Microsoft. This is the official Python extension provided by Microsoft for Visual Studio Code. Okay, and then let this install, and while it's installing, you can go back to the search bar, search in C or C++, C/C++, and again there'll be the most installed one with 40 million installs. install this one. See, just verify that it's provided by Microsoft. Now, this will take some time to install. Okay, now you see the C++ extension is installed. Now, create a new file. You can either go to the file menu in the menu bar at the top, or you can use the Control N keyboard shortcut. Okay, so click create a new file, Control N, and the first thing you do is click on select a language. It will be highlighted in blue, and that's a button. So select a language and type in C. Okay, we're going to start with C now. So select C over here, and here you can just type in your standard hello world program. Okay, so I'm just running through this here. You can use whatever C programs you already have lying around. Okay, and after this, it's done. Now see on the tab where the file is in the editor, above there's a tab specifying what would be the title, so that right at the top it's untitled 1, and you see there's that big yellow dot beside it. So that's what we call dirty. So that means the file has not been saved to disk yet, and to debug any file you need to save it to disk first. Okay, so now we're going to go to the run and debug view. From the left bar you can see that there's an icon with a bug in it, a play button and a bug in it. Click on that and it'll open up the run and debug view. Now there's a big blue button that says run and debug, so you click that, and since the file is not saved yet, it's going to prompt you to save the file. Here I've already, you just go ahead and name it whatever you want to. And now if this line at the top here, C/C++ gcc.exe build and debug active file, if you see this line, that means everything you have installed up to this point is correct. You do not need to debug any installation. Now you can when you click, this is a build configuration that's provided by the C++ extension. So this means that everything has been done correctly so far. So select this configuration for the build and run and debug. And C programs need to be compiled. So this is what it's doing right now in the bottom terminal. So it'll start building. And once it's done, the executable binary file will be run through the debugger. Okay, now it's in the process of running through the debugger. And you should see the debug UI popped up for a second there. And there you see hello world. So right now you have confirmed that your C debugger, everything's set up properly, and you can go ahead and debug C files. Now for Python, we're going to create another file the same way. I'm just going to make a short sample program just to verify that everything is installed correctly. Okay, and again, you can use files that you already have saved, but just make sure you have saved them before trying to debug. Okay, now I'm going to save the file. I guess the file already exists, yes. And click the same button in the left, run in debugger. And again, if you have installed the Python extension properly, if your interpreter is installed correctly, if VSCode is installed correctly, you should see these debug configurations. Now, right now, this is a very simple program. There's no modules, no classes, no packages, nothing. And this is simple Python script. So I'm going to select the first debug configuration. Now this will run it through the interpreter, and there we go. So it's working. Now we are ready to debug Python programs. Okay, so at this point, we have tested the build and debug configurations. We have briefly looked at the process. Now, next, we will focus on familiarizing ourselves with the debug UI. Okay, so what you see on screen is what you have to get used to. It might seem like a lot of panels and a lot of buttons right now, but it's really important that you get used to the UI. See, look at the panels, experiment with everything here and there. And next, after checking out the UI, we're going to take a look at a few simple programs to really emphasize the usefulness of debugging. So I'm going to start off with two definitions, okay? Two terms I need to explain. So the first thing is current line. So control of your program always flows from current line to the next line, and this would be down the screen to the next line and so on. So this can be changed by your function calls, if statements, loops, etc. Okay, really think about this. So the current line under execution is highlighted in yellow over here in the screenshot at the top right. And the debugger will always show the state of execution before this highlighted line is executed. Okay, so keep that in mind. Always show the state of execution before this yellow highlighted line is executed. Next up, we got breakpoints, and I mentioned it before. It's breakpoints. So we are telling the debugger at what points to halt or break the execution of your program. That means pause. It's going to pause the execution of your program so that you can see what's going on. And this lets you quickly get to the desired location in your code. So if you don't want to, if you're debugging a C program and you don't want to debug it line by line from the main function, from the first statement of the main function, you can put a breakpoint in the function that you want to debug. And so it'll execute as it usually does until it hits that function, until it hits that statement with a breakpoint. Now, breakpoints can be toggled by either clicking on the editor margin, like you see the red dot. That's the area which you click, and it'll toggle on with a red dot, and it'll toggle off by the red dot disappearing. Or you can use an F9 on the current line. Now, all breakpoints will be available in the breakpoints view, and if the debugger supports breaking on different kinds of errors or exceptions, they'll also be available here. Variables, they can be inspected in your variable section. You see the variable section to the right, it shows your locals and it shows your registers. And this section of the run and debug view, you can either use this section to the left or your right, wherever you want to put it, or you can hover over the source, the variable in the editor, to see the value. Now, one thing I just want to explain, like a computer science concept, is as your program enters more and more function calls, that's when your function calls another function. So your main function calls square, a stack of function calls is created. You know what a stack is, right? So think of it like a pancakes. You're putting one on top of the other, and so on. It keeps growing, and it represents a trail of function calls for your program, and this is what we call a call stack. Now, all variable values is very important. All variable values in all your expression evaluation are always relative to the selected stack frame in the call stack section. Now, the call stack section is shown in the bottom right, and it's showing the main function right there. So we know that the main functions in the untitled 1.c file on line 9, character 1. And the most important thing in the entire debug UI is the variables, the watch section. So variables and expressions, they can be evaluated and monitored in this watch section. So you can add custom expressions, or you can add variables that you want to keep an eye on to just check the value after every statement executes. Now we're going to talk about the control panel. So first of all, this Braille, it looks like a Braille symbol that's to the top left. This panel is movable, and this, what looks like a Braille symbol, you can click on it and you can drag it across the screen to move this panel around. So the first one is it's a single vertical bar and a play button. That's your continue. So continue means continue the program from where it last stopped because of hitting a breakpoint. Okay. And this basically means, it implies continue execution of the program until it hits another breakpoint, or it finishes execution. Like, that is, it terminates normally. Now, stop exits from the program entirely. That's the red square on the rightmost, on the corner right side. Now we have the step into, that is the arrow facing down with a dot. This, now I want to make sure to disambiguate between step into, step over, and step out. So step into, that's the arrow pointing down into a dot. So what that does is it executes one statement of the program and stops again. And if that statement includes a method or function call, this program will step into that function or method, and it will stop at the first line of that method. So if you have a function A, if you're calling function A on the first line of main, on the first line of int main, if you step into that first line of int main, it will execute that and jump to the first line of the definition of the A, the body of the A function. Now contrast that with step over. What step over does is it executes one statement of the program at that level and stops again. So keep in mind that it executes at that level and stops again. So what this would do is it would execute A to its completion unless A contained explicit breakpoints. So it would execute the entire function of A to its completion and then go to the second statement in the main function. So step over would be the clockwise arrow with a dot underneath. Okay, that's step over. Now step out. What this does is it continues to execute the current function or method until it returns, and then it goes back to the caller. The debugger stops back in the caller. So you'd use step out. Suppose you step into the call of A, and A is called on the first line of main. It's the first statement of int main. Okay, so when you're debugging the A function, you can use step out. So it'll continue execution of till until it reaches the return statement in the A function. And then it'll return to, that is main. It'll return to main. And that means it'll return to the caller. Main is the caller. Okay, now I'll hand it over to Pratham. He's a fellow third year student in the computer engineering program here at VU. And he's going to show you a few situations in which your theoretical debugging knowledge and experience with the VSCode debugger can really help you debug Python programs. Now, all the examples you see today are just simple isolated snippets of code containing bugs. In reality, I mean, you must have already seen this, but in reality, your projects would be hundreds. They'll span hundreds, sometimes thousands of lines. So I can't emphasize this enough. It's really, really important for you to develop that eye for code. You should be able to have that methodical approach to debugging and really hone your skills with the debugger.
All right, thank you for the wonderful introduction, Elvin. So I am going to explain the concept of semantic errors and how to debug using VS Code with the help of these four snippets that I have created using Python. All right, on to my first snippet. So in this program, what we are doing is we are accepting two numbers from the user and then we are adding them. A very simple program. Let's get on running it. So what should the ideal output be if we enter the numbers 3 and 3? It should be 6, right? Because 3 plus 3 is 6. But the output we are getting is 33. So why is this? Because in Python, you can see that we have entered the logic as input, enter a number. So in Python, whenever you enter anything inside the input function, it converts it into a string by default. So to take the value in form of int, we need to use the int function, which is, by the way, predefined by Python. So over here, what's happening is, this is known as function stacking. So first the inner function is executed first, and then the outer function is executed. So input is executed first, which is then converted into int by this function, which is stored inside the variable num1. Same for num2. Let's get on running it. 3 and 3. So here you can see that we are getting the correct output. Okay, on to my next snippet. So in this program, we are converting temperature from degrees Fahrenheit into degrees Celsius. And we have predefined a Fahrenheit variable as 100 degrees Fahrenheit. And we have written the formula to convert the degrees Fahrenheit into degrees Celsius. Okay, so let's get on running it. So the answer to 100 degrees Fahrenheit should be around 37 degrees Celsius, and we are getting the output as 23 degrees. So what could the error be over here? In Python, what happens is, pay attention on the line second. In Python, what happens is, if you don't define a precedence, Python will take precedence from left to right. And multiplication operator and the division operation has the same precedence. So what we need to do is, we need to define precedence using the brackets, which should give us the correct output. So you can see that we have the correct output as 37.7 degrees Celsius. Okay, on to my next program. So in this program, we have defined a list variable, which is my list. It's similar to array in C. And we are accepting 5 int values as integer numbers from the user. And then we are appending each number entered by the user into my list using this dot append function in Python. Let's get on to running it. Enter 5 numbers. So we'll enter 1, 2, 3, 4, 5, 6. So it should have asked the user to enter 5 elements. But here you can see that we have entered 6 elements. So there might be something wrong with the program. So this is a very small program. As Elvin said, you will be facing even bigger programs when you're doing a project or you're working in an industry. So it will be very tough to find out the errors. So it can be simple using debugging. So we use debugger over here. We need to input breakpoints, which will help us resume and pause the program. And generally the loops should be your go for points to debug. So let's start. Okay, so over here in the variables column, you can see our variables. This I is the iteration variable, which we have defined as 0. This my list is the list variable, and you can see the length. And n is the amount of numbers which we want to accept, which is initialized as 5. So we are going to continue, which will execute the current line that we are on. So we'll enter our first element. Now keep a watch on our variables. The I has incremented to 1, and this 1 that we entered was appended into my list. Let's keep on continuing and enter our elements. Please make sure that you are keeping a watch on our variables. Okay, so here you can see that I went up to 6. But what we wanted to do is, we wanted to accept 5 elements. So now we can see that we have a problem with the I variable. So where's I variable in our program? So here there can be 2 solutions. Either you can initialize I by 1, or what you can do is, instead of while I is less than equal to n, we can do I is less than n. And then we save it. And then let's run it again. And we enter our elements. Okay, great. Now we can see that it's working perfectly. On to my next program. So in this fourth program, we have created logic for a function to calculate factorial. This def is used to define a function, and the name of our function is factorial. And then we have written logic to calculate the factorial, and then we have called our function and passed in the parameter as 4. So it will calculate the factorial of 4, which should be 24. But if we run it, we are getting the answer as 0. So there might be a problem in our logic. Let's debug it. First, we need to put our breakpoints. let's put a breakpoint near the fact variable. And don't worry, you'll understand how to put breakpoints once you gain the experience. You'll know how to localize your breakpoints. Okay, so in our variables, you can see our fact variable, which we have initialized as 0. I is the iteration variable, and this n is the argument that we have passed in the function. Let's continue and keep a watch on our variables. You can see that each time we click on continue, the index variable I is always incrementing, but fact is always 0. So there might be a problem with a fact variable. So what might be the solution over here is we have initialized fact as 0. And in our loop logic, what we have done is fact equals to fact into I. So whatever may be the value for I times 0 will always become 0. So it will return 0 every time. What we need to do here is we need to initialize fact by 1, sorry. And then we save it. Terminate the debugger. And let's run it. Okay, so we are getting the output as 24, which is correct. So this was all from my side. Thank you for paying attention. Over to you, Elvin.
Thank you, Pratham. Now, next we have Zaki from the second year who will take over. He's going to show you one example of a syntactical error and one of a semantic error in C, and he's going to debug them.
So hey everyone, I am Zaki Patel and I'll be explaining you semantic error with a simple example. Since it is easy to explain and understand Hindi, I would like to go for it. So semantic error समझने से पहले समझते हैं basically syntax error क्या होते हैं. तो syntax error में अगर आप grammatical mistake करते हो या आप किसी भी language के rule को violate करते हो, जैसे यहाँ पे मैंने एक semicolon miss किया है, तो वो syntax error show करता है. सिंटैक्स एरर में VS कोड में आपकी फाइल ऑलरेडी रेड होती है और सिंटैक्स एरर की फाइल रन या कंपाइल नहीं होती है. लाइक इफ आई ट्राई टू कंपाइल और रन दिस, इट विल शो एन एरर एक्सपेक्टेड एंड सेमीकोलन ओवर हियर. सो इफ आई जस्ट पुट अ सेमीकोलन ओवर हियर एंड रन इट अगेन, माय एरर सॉल्व, योर आउटपुट इज 25. सिमेंटिक एरर में ऐसा नहीं होता है. सिमेंटिक एरर बेसिकली वो होते हैं जिसमें आप ग्रामेटिकल मिस्टेक नहीं करते हो, आप सिंटैक्स को ब्रेक नहीं करते हो, लेकिन आप एक लॉजिकल मिस्टेक करते हो. सिमेंटिक एरर किसी भी कंपाइलर को पकड़ना इतना आसान नहीं होता है. वो it does not show any error. Like if I run this file, it will not show me any error and it will run correctly, but I will not get my desired output. या जो मेरा expected output था मुझे वो नहीं मिलेगा. Like if I enter the first number here 10 and here second 2, I should have got 5. मेरा desired output था 5, लेकिन मुझे वह नहीं मिल रहा है. मेरा यहाँ पे प्रोग्राम टर्मिनेट हो रहा है. तो इसी को सॉल्व करने के लिए डिबगर यूज करते हैं. डिबगर बेसिकली हमें एरर्स ढूंढने के लिए हेल्प करता है. सो इफ आई वुड डिबग माय प्रोग्राम, आई स्टार्टेड डिबगिंग माय प्रोग्राम. सो हियर आई विल पुट 10, हियर 2, इट स्टार्टेड. सो यहाँ पे हुआ ये, यहाँ पर num2 मेरा 2 है. नाउ आई विल स्टेप ओवर. नाउ माय num2 हैज ऑलरेडी बिकम 0. आई विल स्टेप ओवर and here my program is terminated. यहाँ पे exception as आया है, arithmetic exception. So basically हुआ यहाँ पे ये है कि मेरा प्रोग्राम यहाँ तक सही से चला है. I have entered the first input, second input. अब if statement में आया है, इसे यहाँ करना था कि वैल्यू को कंपेयर करना था, लेकिन I have used an assignment operator instead of comparison operator. तो यहाँ पे हुआ ये कि मेरा num2 automatically 0 assign हुआ है, जबकि वो कंपेयर होना चाहिए था. सो इफ में यहाँ की इसके स्टेटमेंट ना ट्रू हुई ना फॉल्स हुई और वो सीधा एल्स में जंप कर गया. अब एल्स में उसको रिमाइंडर इक्वल टू num1 बाय num2 करना था. तो उसकी वैल्यू num1 की थी 2 और num2 की ऑटोमेटिकली 0 हो गई. अब किसी भी नंबर को अगर 0 से डिवाइड करते हैं तो वो इनफाइनाइट में चले जाता है और अपने कंप्यूटर की एक फिक्स मेमोरी होती है. अब इनफाइनाइट मेमोरी तो नहीं हो सकती, इसीलिए उसने इस कंपाइलर ने उसी को यहीं पे प्रोग्राम को यहीं पे टर्मिनेट कर दिया. सो इफ आई विल पुट एन कंपैरिजन ऑपरेटर इंस्टेड ऑफ एन अरिथमेटिक ऑपरेटर and I will run my program again. Input 10, second 2. I've solved my error. The division of two numbers is 5 and I've got my desired output. With this said, I would like to conclude my part and pass on to Elvin again. So thank you everyone for your attention.
Thank you, Zaki. Now we have Akanksha, who's from the first year, who's going to show you another C snippet. And this one can be very frustrating to fix until you use a debugger, that is. So over to you.
Thank you so much, Shelvin. Now, here I'm going to present you with a snippet of addition of two float numbers by passing values. Now we will debug this program. Now, as you can see here, while taking the values, it is not taking values those we have mentioned while initializing the variables. This is because of the error which happens here, which is called as implicit typecasting, which means while declaring the variables, we have used float as our data type, but while initializing the variables, we have used int as our data type, which leads to this problem. So automatically, due to the usage of int, it converts the float values to an integer data type. And the answer of the addition, like the result, is also an integer data type number. So as to solve this problem, we can change this int to float and this also to float. And we would like to debug this program again. Now, if we debug this program again, we would get our expected results, that is, while taking the values, it takes the values we've initialized in the int main, those are in points, that is the float data type, and even the result is as we want it to be, that is in float. And this is my program. Thank you so much. I would like to pass back to Alvin.
Thank you, Akanksha. Now, we have used a few examples with C because that's what you have been learning in your college courses. Again, this demonstration is aimed at undergraduates or those who are amateurs at programming. That means your undergraduates who are still taking their introductory C, introductory Python courses. And however, I will say debugging is a skill that translates to any language and any framework. It's a universal skill. So going forward, when you start messing with, you're going to see a lot of things like web development, Android development. You're going to be creating your own games, your own desktop applications. And if you face the same problem of unexpected output or undefined behavior, I want you to have a mechanized and methodical approach to squashing these bugs. Okay. And my original inspiration, or actually the original inspiration for this meet was I I cannot put into words how much this helped me in my data structures and computer graphics courses. And this may or may not have helped me score an outstanding grade in all my online exams. Again, may or may not have helped me to score an outstanding grade by allowing me to step through and step over and inspect using the watch list, the variable watch list. It may or may not have helped me to view the status of all the data in the stack, in the queue, in the trees. It may or may not have helped me visualize balancing trees, whatever algorithms I've learned. It may or may not have helped me visualize all the sorting algorithms and keep track of where the pointers are while sorting sorting an array, or uh, in the case of a stack, uh, for your infix, your postfix expressions, I believe you used a stack. So it may or may not have helped me in the exam. So that was my original inspiration for this. And actually, when I went offline to college, I was quite surprised that most people had gotten quite a low score in all those subjects because they were not street smart. They weren't solving it the way I was solving it. So they were actually trying to visualize the stack on a piece of paper, while I may or may not have used the debugger on my laptop during the exam, may or may not have, to solve the questions. So I hope this helps you in the future. I hope you take this disclaimer that I've put, and I hope you exercise using debugging to solve Now you don't have online exams. So I hope this helps you solve all your problems with your assignments, your problems with any of your coding challenges or Viva assignments or anything, any modifications that you need to make to repositories that you find. So that is my intent and my idea behind this whole demonstration. So now I'll hand it over to Neha, who's also from the third year in the computer engineering program at VU.
Hello. Uh, well, I thank you all for joining and giving us your really appreciated time. Like, I really appreciate, guys, that you have joined the program. And going forward, like for more information, you can also do check the sources, debugging links, which and we have this famous quote here, and reference link for the readings are provided to you. Thank you for watching this session. Please check the description box for the links for the installations and instruction documents. Thank you, guys.